So let's do some more work on our data set. One of the useful things is to actually see if one data set, one column of data, the mean of it is the same as another one. So if we take a look at our data set here, call it up, we've got a variety of different things that we've weighed out over a period of time. So we've got massive salicylic, massive acetic anhydride, and so on and so forth. So there's things that we can compare to each other and actually see if they're the same or different. Just for this instance, we're going to do some basic t-test, and we're going to do it on the weight of massive salicylic acid and the mass of acetic anhydride. And we're going to do it for the entire data set, so it'll be pretty straightforward. Um, the result we're expecting is it's different because you're supposed to weigh out 5 grams of this and 8 grams of this. So the hope is that these are different values, and we'll see how that goes. So I'm going to call in a new file here, or a new notebook, and the first thing we're going to do is we're going to import pandas as PD. And I see that everything seems to be working for me today because the import is highlighted. And we're going to use something called SciPy. So we have a couple of statistical libraries or classes that are out there that we can use. SciPy is a very popular one as well. Pandas has some stats in it, but mainly it's for manipulating and reading stuff in from the data frame. This is going to import our stuff into it. So let's just run that cell and make sure everything's okay. And now we need to read in the data file as a um, uh, data frame. So I'm going to go CSV, and I specifically want this one here. And so what I do is I typically will right click, I'll copy the path, and I'll put it right here, and I'll go Control V. And that will get me the whole proper name. But as I said, for some reason, when I use that actual path, it never seems to want to call in the information. So there we go. And to make sure it's working, let's try to get the columns read and just take a look and see if this is going to work. And so I've done something wrong. What it is, I don't know. And maybe I need to put in, yeah, I forgot my little quotes. All right, so there it is. Everything's read in, everything's fine. And so we have our data frame as DF. So first thing we need to do when we do a lot of stats, we need to sanitize the data. And for doing a t-test, it doesn't take nicely to missing values. So our data frame then, DF, we need to get rid of any NA values, as they call it. So we're going to drop NA, use the drop NA function, and get rid of any sort of missing values. So I'll hit run for that. And so now we have our data frame that has no missing values. It deleted all that stuff. And so now we're going to perform the statistic. Now I can write it in, but I guarantee I'm going to do it wrong. So I'm just going to copy it from somewhere that I have here hidden. And this is the statistic. So we're going to create a new variable here and a p-value. So these two variables are going to be created, and they are going to be based off of the t-test that is built into SciPy. So we imported stats here, and so using the stats library or the class, we're going to call in the function t-test and start to work on it using our two columns, massive salicylic and massive acetic anhydride. And note at this point, we could actually change any of these columns as long as it was sort of continuous data, meaning that was numbers. We can actually you bring in any one of these columns. And so it's only two data sets that we can do, only two means that we can compare in a t-test. If you want to compare more than one, more than two columns, so three columns or more, you're going to go to an ANOVA. So the one thing missing here, then I'm gonna just run that, is we need to print this. So again, I'm going to call this in here. I'm going to cheat a little bit, and this is what I'm going to do. So now if I print the word t statistic, and then in curly brackets here, this is this variable right here like this, and then p value is a string that I want printed out, and then in curly brackets here, this is my next variable right here, and then it's going to print it out for us. So it's going to look very nice, and let's see what happens when we do it. Yay, there it is. So The value here, the t-statistic, is very, very, very small. So if our value was 0.05 or greater, then we would say that these two means, these two here, are the same. But this is really, really small, 10 times 10 to the negative 127. So it clearly is telling us that they are not the same. But this is for the data set for the entire number of years, right? Over the course of time. What if we wanted to start comparing data sets between years or between lab days? Well, we can start using our group by function to help us out with that. So let's say we want to do our t-test, but we'd like to do it by year. So we want to compare the mass of salicylic and mass of acetic anhydride, but rather than for the entire data set all the way down, we want to compare this year, so 2023, the mass of salicylic here and the mass of crude ASA here. So, oh, sorry, these two, acetic anhydride and salicylic. But we also want to do it for 2022 and 2021 and so on. So we want to compare for this year, compare these two values. For this year, compare these two values. And rather than writing out this several times, like we would do essentially in Excel, we can script this in code to actually do it for us pretty easily. So we're gonna open up another notebook and we're gonna get our friend pandas in. Um, we're gonna import NumPy this time. So NumPy is a way of organizing data in an array. It comes in handy for doing this. I'm not an expert at arrays, so I typically use AI to help me out with a lot of this stats and math to try to understand. And finally, we're going to use SciPy again like we did last time. So we'll run this cell, get that going, and now we need to call in our data. Um, so from pandas, we're going to read our CSV file, and again, I want to copy and paste this. Let's try not to do what I did last time. And I need a quote, another quote, close the brackets, and to make my life easy, I will get rid of that. And to make sure it works, I'll just see if the columns will come in like this, and there they are. The columns came in, yay. Note that I didn't need that. And so now, again, for the stats, we need to get rid of any of the null values or any of the missing values. Now, last time, the last video we did, we got rid of all null values. So for every one of these columns, if there was some missing data, it would get rid of everything for that entire row. But we really don't want it for everything. If there's missing data here in crystallized, we don't want it to affect the mass of salicylic and the mass of acetic. So what we're going to do is we're going to be a little more specific in dropping this stuff. So I'm going to copy this code in, but you'll see it's very similar to what we did before. So we're going to drop NA like we did before, and what we did was we just had open close brackets, and that would affect the entire data set. But we just want the subset. We want specifically mass of salicylic and the mass of acetic anhydride, and we're going to say this in place equals true. If we do that, it's only going to remove the values from either this column or in this column, but that's it. If there's missing values from anything else, it won't remove those values and we'll be able to keep them for our analysis here. So let's run that. And now that we've done this, we can actually do our stats. Now I've got a function here that will apply to all of it. So let's try this one out. And so what we're going to do is we're going to group. So we've done the group by function previously. We're going to group by year. So using the year, so we're going to see all the data being organized in 2023, 22, and so on. And then we're going to apply. So what we're going to do is we're going to use this function called apply and something called lambda. And so on our data frame, then we're going to apply the t-test to these two columns. So that's essentially how that works. If you want more information, again, you can go either to Google and start to literally copy and paste this in, but I find that now using the AI tools is even better. If I were to copy this plus all the other bits of code above, put it into Copilot or ChatGPT and just say explain this code, it'll actually explain it quite well to me. All right, so let's see what happens here if it actually comes out, and it did. So what this is doing now is year by year, it's comparing the mass of salicylic and the mass of acetic anhydride. And so again, our p-values are very, very low. Everything is in the negatives here. So the mass of salicylic and the mass of acetic anhydride for every year, the means are not the same. If the means were, if the value, the p-value was above 0.05, then that would tell us that the means are the same. And so this is the kind of statistic that we're going to do when we recrystallize ASA. So we're going to synthesize aspirin, and then we're going to recrystallize it. And the hope is that when we recrystallize it, it actually gets better. But we're going to prove that by stats. So we're going to do a variety of melting point tests on the crude product and melting point on the pure product. And we're going to compare the two and actually see statistically, are they the same value, the means of those the same or not. We're also going to do an ANOVA and compare all our means to previous year's values as well. So I'm going to also save this t-test year. All right, don't forget to do that. And the other one, always save your notebook just in case the browser goes out on you, which has happened to me in the past. So what we did was we were comparing and doing a t-test on two values that we already knew were going to be, completely different, but it was fun just to check it out. But let's say we want to compare year by year. So I want to see if the year 2023, if the mass of one of these is the same as in 2022. So let's say we've got last year's data and we want to see if this year, if it's the same or different. So we have no idea if that's true. So we're looking at, say, we'll do massive crude here. Look at these values like 4, 3. So this is the amount that was produced. And so at one point it's 10 grams. The variation is enormous on this. And so as we get down to 22 data, there's one that's 1 gram of massive crude that was produced, 7 grams, 6 grams. So 0.5 grams, wow. So we've got a huge variation. So is this the same? Is this the student data set here? Did they produce the same amount of crude ASA as the year 2022? So for the code for that, I'm going to compare two different methods that deal with this. So the first one here, let's try this one. So similar to what we did before, we're going to import pandas as a PD, and we're going to import SciPy. We could import stats here as well, and it'll still work. What happens is if you do this, it's supposed to work quicker. Rather than importing the entire library of SciPy, you import one specific one, and supposedly it'll work quicker. Really, you could just import SciPy and you're done. Stats is in there, t-test is in there, all of it's in there. So really, we could have just imported SciPy and have it be done with. We're going to read in our data file, so this Chem 10046 lab as well. And now we need to, now that we've created the data frame and we've called it data, set it to a variable data. Instead of df, we use data this time. So we're going to create two new variables. One is going to contain the data for 2023 and one is going to contain the data for 2022. And specifically, we want the year equal to 2023. So we're going to say data in this data frame here, the specific column year, we want it to equal the 2023. So this variable right here, take the data from the year column, 2023 specifically, and I want specifically the mass of crude. And we're going to drop any null values. So again, another way to drop null values without having to get rid of all sorts of other data out of it. And I can actually add these functions one on top of each other, one after each other, and keep the programming short. I'm going to do the same thing for 2022. So I'm going to call in the data and then I'm going to sort by year and exactly 2022. And I only want the column of mass crude ASA and drop any null values from that as well. So now I've got the two variables that contain the data for the year 2023 and specifically the mass crude of ASA. I could call in any other columns if I wanted to and compare the two columns and see what those data sets look like. So similar to the basic statistics, I'm going to call in this t-test from the SciPy, and it's a t-test independent. And I'm going to call the one variable t statistic and the other one p-value, and I'm going to specifically compare these two data sets. So the variables here, 2023 and 2022. Also, what we're going to do is we're going to print out what the statistic value is and the p-value is, so the t-value and the p-value. And once we get those, we got a little code here to just remind us if the value is less than 0.05, then we reject the hypothesis that the means are equal, meaning the means are not equal. It's a long way of saying that. And then else if it's greater than 0.05, then the means are equal. So if we run this, which I already did, we'll find that the p-value here is much less than 0.05, and so based off our little code, it's telling us we reject it, that the means are equal, meaning that the means are not equal. So I don't like the language they use in stats sometimes. Why can't they just say the means are not equal? I guess I could have typed that in. But so that was one way of doing it. There is a second way. It's very, very similar, but we're going to use the group by function. So here we read in the data frame, we created two variables, and using the pandas data frame uh, information, we just said exactly equal to 2023. I want this information. So it's a way to group and sort the information, but this other one uses the group by function. So it's very similar. So I'm just calling in these two, and you can see from SciPy I just imported stats. I didn't import just the t-test. I could have. And I could have just said import SciPy, and that would have been fine too. So again, we're going to read in the file into a variable called data, but this time we're going to do the group by function on it. And so now we're going to create another variable, and the other variable is going to be our data frame grouped by the group by function based on year. So now at this point, this variable contains all the information for year 2023, 2022, 20, and so on and so forth. And so I can use within the group by function another one called get group. So here I'm going to create a variable called 2023, much like I did on the previous one. And so using the grouped data right here, this variable group data, so there's my variable, I'm going to apply another function. So I've already got a group by year, but now I specifically want 2023. So on this group data here, I'm going to apply the function group by to get it into year. Then I'm going to create a new variable. On this group data, I'm going to pull in the get grouped specifically for the mass of ASA, crude ASA, and I'm going to drop any null values out of it as well. And so now I've got my two data sets, just like I did on the previous one. I can do the exact same statistic that I did on the previous one with these variables, so it's essentially the same. And I'm going to print out all this fun little stuff. And the values are the same. So 3.7 and 0.0004 values are exactly the same. The only difference was one used the group by function and one did not use the group by function, where it just called the data directly into the data frame. You can use either one of these, but I do find using the group by function to be, for me, more logical and easier to deal with. So I prefer this one, but I just wanted to show you both methods to actually figure out the t-test if I was just comparing year after year. You could also then do the same thing with lab day. So obviously if I change this to group by lab day and I wanted to compare get group A versus group B based on mass accrued ASA, I could get the exact same information to come out. So I could go here and I could highlight this and I want group A versus group B. And now I don't care about the 2023 because I'm grouping by lab day and I'm going to specifically call in group A and group B. And so you could do the exact same thing over and over again for a variety of data, and I could apply it to any column. So instead of mass crude ASA, I could call in percent yield ASA, I could do it for the crude, I could do it for any one of these columns and do the exact same thing. Similarly here, I can call in the data by year, or I could call it lab day, and I could say specifically lab day A and lab day B. And here I could call in whatever column that I wanted. So I could call in back here, I could call in percent yield or mass crude ASA or any column that I was interested in to actually do the work. So hopefully that works for you. I'm sorry I didn't type it in like most people do on YouTube, but it's a lot of work.